In this video, I will be covering exactly how polar graphs are drawn. If you haven't seen it already, I made a previous video about polar coordinates, which might make parts easier to understand. Now, we first need to talk about radians, as they are very important for graphing polar equations. So, we are all likely familiar with degrees, which go up to 360 degrees for full rotation. Now, if you ever thought 360 was a bit arbitrary, that's because it is. That's why we use radians, as they are based on geometry. If we imagine we have a unit circle, so a circle of radius 1, we might want to describe angles by how far around the circumference we go. So 180 degrees would be this distance, 90 degrees would be this distance, and 360 degrees would just be the whole circumference. So if we just get the circumference, which is 2 pi, we can do that. Now, 180 degrees is pi radians, and 90 is pi over 2 radians. We are now describing an angle as the distance along the circle. Now, as we saw previously in polar coordinates, we have a distance r and an angle theta. When we graph a function, we usually treat theta like x, where we change it and watch how r changes in reaction to it. So now, let's try this with a function like sine of theta is equal to r. Let's start by plotting this like we would with a typical function and create a table. So, for theta equals 0, we get 0, for pi over 2, we get 1, and for pi, back to 0. Now we continue on and fill up this table. We now have a list of polar coordinates, which we can plot down and get this. We can now connect the dots and we get a circle for sine of theta. Now, why this works better than Cartesian for certain equations is if we look at Cartesian plots, it does not account for repetition. Here on a plot of cos of x, we reach x equals 2 pi, and then it just repeats. But when we use polar coordinates, you can notice that the point 1, 0 and 1, 2 pi are actually the same point, as we have completed a full rotation. This helps us encapsulate the behavior of the function. Now I'll leave you here with some cool polar graphs drawing themselves. Enjoy! If you enjoyed the video, please like and subscribe. I hope you learned something new, and have a nice day.